One of the hardest problems in astronomy is determination of distances. We know things are extremely far away from Earth, so measuring distances is not as simple as laying down a ruler. For many years, our understanding of cosmology was inhibited by the fact that we had no idea how big the universe really was, because we couldn't measure the distances to galaxies. One way to determine distance is with brightness. Imagine you have a 100-watt and a 1-watt light bulb exactly the same distance away from you. The 100-watt bulb appears much brighter because it's intrinsically brighter. It's giving off more light. The brightness a star would have at a known fixed distance is what astronomers call absolute brightness. If you were to take that same 100-watt light bulb and move it farther away, it would appear dimmer. Less of its light is reaching you. How bright something looks to you from wherever it is called the apparent brightness. If you know how bright something should look, then measuring its apparent brightness will tell you the distance. In the early 1900s, an astronomer at the Harvard College Observatory named Henrietta Swan Leavitt was studying the Large Magellanic Cloud, which we now know is a satellite galaxy to the Milky Way. She was looking at a kind of star known as a Cepheid variable. Cepheid variables change their size over time in a never-ending cycle, getting bigger, then smaller, then bigger again. The entire cycle takes several days to repeat. The time for one cycle is called the period. This cycle of pulsation has observational consequences. The brightness of the star changes with time, getting brighter and dimmer in the same regular pattern with the size. What Leavitt discovered was that the Cepheids that were intrinsically brighter took longer to cycle through the pattern of brightness and dimness. This meant you needed two instruments to determine distance, a clock and a telescope. You can use a clock to determine the absolute brightness. You could use a telescope to determine the apparent brightness. The difference between these two would tell you the distance to the star you were looking at. This is one of the most important discoveries in the history of astronomy. It allowed us for the first time to determine distances far outside our own galaxy.